हेलो स्टूडेंट्स, आज मेरा क्लास हाइड्रोजन स्पेक्ट्रम पे है। सबसे पहले हम लोग समझेंगे स्पेक्ट्रम क्या होता है, स्पेक्ट्रम कितने टाइप्स का होता है, उनमें क्या डिफरेंस होते हैं। सबसे ज़्यादा फोकस जो आज के क्लास में होना है वो है एटॉमिक स्पेक्ट्रम क्या होता है। तो सबसे पहले समझिए स्पेक्ट्रम क्या होता है। आपने पढ़ा है when a white beam of light passes through a triangular glass prism, then it splits up in radiations of different wavelengths and frequency and makes a pattern which we call a spectrum. So we must understand the spectrum. A spectrum is just a splitting of a white beam of light. So a beam of light is passing through a trigonal prism, and this light when enters into the glass, then it breaks down into its constituents radiations of different frequencies, wavelength. This splitting of light is called dispersion. This splitting of light is called dispersion. And the pattern of the colors or the patterns of the radiation, this pattern is known as a spectrum. Now the question is types of spectra. Here we divide this spectra into two main types. We call this continuous spectra, and the other is called line spectra. So there are two categories of spectra. One is called continuous spectra, the other is called line spectra. What is the difference between these two types? So see, what is spectral lines first? Spectral lines. This represent a particular wavelength or a frequency radiation. So here, if we have a white light beam, all of we know this white light is made up of 7 colors, and these 7 colors are written here starting with violet, then indigo, then blue, then green, then yellow, then orange, and then red. We have 7 colors and we call it Vibgyor. So these are 7 spectral lines which is appearing in the white light zone, and we call this spectral lines. Now the question is it continuous or line spectrum? The only difference is when the spectral lines are overlapping with each other, when the spectral lines are overlapping on each other, that makes it continuous spectrum. And if the spectral lines are not overlapping on each other, each line is, we call it bright line and the dark line. So every color, if the color is this violet and then there is a gap which is dark, then it is indigo. So what we see here, the overlappings are not there, so that is why we call it line spectra. We are done with continuous spectra and line spectra. Let's now understand other types of spectra. The other types of spectra, again we classify spectra into two groups. So spectra are then further classified into two groups. This time it is emission spectra spectra and absorption spectra. Emission spectra and absorption spectra. What is the main point? When the source of light, suppose I have a candle here and this candle is producing light. So if I place a wall here, and make a slit, a narrow line slit, to make a beam emanating from this and falling on the prism, See, this is the source of light. Now it is passing through a prism, so that beam of light is created. Now this beam of light is passing through the glass prism and it splits up into constituent radiations. This is called emission spectra. Now, if the source of light before passing into the prism, it is first allowed to pass through certain chemical sample. Suppose I have a beaker here, and in this beaker certain chemical solution is there, chemical compound is there. Now what is happening? The light rays are first passing through this chemical compound, and then this light is now allowed to pass through again a slit, and this light falls on the prism. The light beam now also splits into the constituents colors. This makes absorption spectra. In absorption spectra, what will be the thing which is important, interesting? Some of the colors will be missing. So what was earlier? Earlier, the spectral lines were overlapping on each other. It was very difficult to separate the violet from the indigo and indigo from the rest of the rays, rest of the colors. It was very difficult to separate. So that was continuous spectra. But when the source of light is made to pass through certain solution or vapors of a chemical, then the spectra is just like a line spectra. It's not continuous. Its continuity is missing. Okay, so it is now made up of only few colors. So these colors appears separate, bright, dark, and we call this line spectra. So it's now very clear, absorption spectra is usually a line spectra and emission spectra is usually a continuous spectra. Now, we'll discuss about what is hydrogen spectra. Here, when I say hydrogen spectra, this is very, very important, of very high scientific value. Here, the first thing is the light. What kind of light we need to make it into a spectra? We need a particular device which will produce light from hydrogen gas. How hydrogen light will be obtained? That is the main point. So hydrogen light will be emitted from a device we call discharge tube. So suppose I have a discharge tube here. Discharge tubes are fitted with cathode and anode, and then they are connected with high source of battery, high powered battery. So these high powered battery provides electricity, and here in this discharge tube, hydrogen gas is filled with at a low pressure. When a high voltage of about 10,000 volt, 10,000 to 20,000 volt is applied across this, then hydrogen gas starts emitting radiation, and this radiation is now allowed to pass through again a slit, and this light now falls on the trigonal prism, and this trigonal prism splits this hydrogen beam of light into its constituent colors, and here the constituent colors are not made up of 7 colors. Only 4 colors are there in hydrogen spectrum. In the visible zone, there are 4 spectral lines coming, and all of we must understand these lines are red line will be at the top because it will have highest wavelength, and the one which is lowest wavelength is the light which we call violet light. Okay, so one is red light, the other is violet light. It has lowest wavelength and highest frequency, and then we have 2 more light rays, one is blue green and the other is green violet. Okay, so here I am writing after red it is blue green light, and the third one, the middle one is blue violet, not green violet, blue violet. So you need to understand there are only 4 spectral lines in hydrogen spectra. Now, important thing is that is there any other lines? Is there any other radiation coming? All of we know that in a spectrum, we divide the spectrum into 3 zones. The zone which is falling almost in the middle is the light which we call visible one, visible radiation, and towards the right side we have invisible radiation, and on the left side also we have invisible radiation. So both sides we have invisible radiation. Now how it is different? As we go from left to right, wavelength or the lambda part, wavelength increases, and if we go from right to left, then frequency increases. Frequency is denoted by nu, so frequency increases. So that is why here it is the red light and here it is the violet. They lie on opposite ends. So red one has higher wavelength and the violet one has higher frequency, and that way we divide the spectrum into 3 zones. So of course here there are some radiations coming which is not sensed by our eyes, So this is invisible zone, and this one is also invisible zone. Okay, so in the invisible zone we have here infrared radiation, then we have microwaves, then we have radio waves. So radio waves have highest wavelength. Now coming to this side, just after the violet zone, we have a zone of invisible radiation, and we call it UV radiation, ultraviolet radiation. And after ultraviolet radiation, there is another zone, invisible zone, we call this X-ray zone, and thereafter it is gamma rays, and then it is cosmic rays. So this is all about a spectrum. Now let's discuss about what is atomic spectra. What is atomic spectra? Hydrogen spectra is an atomic spectra. Why so? Can we have a similar kind of spectra by any other element? The answer is yes. All atoms, whether it is atom of hydrogen or is it atom of sodium, they all produce a specific kind of light. Okay, so hydrogen has four spectral lines. Similar way, sodium has dominant yellow color light. That does not mean that only yellow color is there. It is again a mixture of many colors, but dominated by yellow color. If I see the pattern of sodium spectra and that of hydrogen spectra, we will see that they have a different pattern. They have a different kind of spectra. One thing very important that we have to understand, a spectra made by atoms is called atomic spectra. Hydrogen spectra is an atomic spectra. Similar way, sodium spectra will be a atomic spectra. So how sodium light can be produced? Of course, by the same method, we'll place sodium vapors in the discharge tube, and when a high voltage source is connected with the discharge tube, it will produce yellow colored gas, and that colored gas can be converted into atomic spectra. So scientists have the pattern of spectra for hydrogen, scientists have pattern of spectra for sodium, and that is how they identify different elements on the basis of a spectra. So let's now understand, we have a separate branch of science. We call it a spectroscopy. Here in a spectroscopy, we use line spectra to analyze different kind of chemicals. Line spectra can be also classified into two types. One is called atomic spectra. The other one, we can call it band spectra. What will be the difference? If I have the atomic spectra of hydrogen, only hydrogen atoms are involved. If I have a spectrum of CH4, methane gas, here there will be combined spectra of carbon atom as well as hydrogen atom. So this spectra will be different from this spectra. And if we have a previously defined or previously printed spectral lines on a photographic plate, we can just match them and say this is methane spectra and this is hydrogen spectra. And that is how scientists uses the science of spectroscopy to identify the different chemicals.